A function is a mathematical equation that assigns inputs to specific outputs. Now, we're going to get a lot more technical than this, but let's begin with problem 1. So, if I type in the code for hot Cheetos, right, let's say it's A3, and I put in the right amount of money, and I push a button, out comes hot Cheetos. Now, if I put the wrong amount of money, or if I put a different code, I'm going to get a different output or a different outcome. If you study for a test, hopefully the probable output will be a better grade because it reflects on your understanding. If we give a plant water and sunlight, we're going to get oxygen as one of the outputs. An automobile engine, if I give it gas or burn, is going to go ahead and provide the energy required to do work and therefore move the car forward or backwards. Now, on a true or false question test, you have a couple of options, literally. You have two options. It's either true or it's false. So depending on which one you pick is the output you're going to get. It's either correct or incorrect. As far as a football is concerned, so we have many actual functions that model trajectories of football. If you take physics, we're going to be talking about kinematics and free fall. Some of the variables that go into determining how a football is thrown are the angle, the initial velocity, and any drag that the football experiences. But we bring up problem 1 to show you that inputs determine outputs. Okay, and that's very true for life, right? I mean, what you put into it is what you're going to get out of it. So, life is a function, and a function assigns a unique value to each input of a specified type. Okay, so the input is usually labeled x, and for example, we have f of x, okay, is read as f of x. I just said f of x. So this is a little symbol right here, f parenthesis x, okay, that's read as f of x. So here are some examples of what functions look like. We have this orange function, f of x equals x squared. It's a quadratic function, which we're going to discuss more in the future. The green function, g of x, is equal to the absolute value of x plus 1. Recall that absolute value means that we do the operations in between and inside of these two absolute value symbols, and that whatever happens in there then comes out as a positive value. So for example, if x were negative 3 plus 1 is negative 2, but the absolute value of negative 2 is positive 2. So be aware this is an absolute value function. You covered absolute values in pre-algebra, algebra 1. The blue function, h of x equals 3x minus 5, is a linear function. Linear because this is the equation of a line. Okay. So these are just some examples of what functions could look like, and we'll show you some more functions as we go along. So let's consider a function, and this is going to be a general example of what a function does. So this right here is a machine. This is the actual function itself. Okay, and what happens is I'm going to input a value of 3. So I'm going to drop a 3 into this vending machine. Okay, the vending machine is going to do its fanciness, and it's going to spit out a value of 7. So a function is essentially a vending machine for math. You give it a number, it pumps out a unique number as a result of that. Okay, so if the input is x, this right here is a function, and that's the machine. Will the machine always be the same? Will the function always be the same? No, functions are unique, and the inputs we put into them are unique, and the outputs we get out of them are unique depending on the mechanism of the function. So in this case, the function itself is 2x plus 1. So if I were to write this out, this function is f of x equals 2x plus 1. And what we're proposing is, what if the input were 3? So in other words, if I plug in a 3 for x, what would the output be? What would the outcome be? So I am using my parentheses to substitute. I do the order of operations. 2 times 3 is first, which is 6, plus 1 is 7. And so we say that f of 3 is 7 in this case. and only in this case for the function that is defined by 2x plus 1. You might want to try out, for example, consider trying out some of these on your own. What would f of 0 be for this function? So if I put in a 0, what would the output be? Or what if I plugged in a negative 1 instead? Or what if I plugged in a 3/2? These are the outputs you would get. May I suggest you prove that these are true? And if you are uncomfortable with fractions, well, welcome to Algebra 2. For your summary, and some of you are not doing these summaries, and I can tell. Please do these summaries because it helps you to understand the material. And if you need assistance with the summaries, reach out to me. Let me know what you think. Explain problem 3 in words. Try to start using these ideas, these concepts of input, output, function. Okay? And if you need some help, I'm giving you a fill in the blank. All you gotta do is fill in the blanks. But if you can go deeper than this, you should go deeper than this. Let's look at problem 4. So for problem 4, we're given 4 different functions, a, b, c, and d. And for each of them, we want to find out what f of 2 would be. So in other words, what we're asking you for these problems is if you use an input of 2 into each of these vending machines, what would the output be? So some of you have been craving mechanical algebra. This becomes pretty mechanical. So for example, part A. Wherever I see an x, I'm going to leave it blank or put parentheses, and I'm going to input 2. So this is an empty machine. I'm going to put a 2 into this machine. I'd follow order of operations. 2 plus 2 is 4. And so for A, f of 2 is equal to 4. That's it. That's it. That's it. Let's look at B. Remember, key to this is let's leave some blanks available for us to insert the input. And I'm using parentheses, which is very important. Now, we're going to plug in a 2 to B. Order of operations as we do this first. 2 squared is 4. And then I have the plus 2. And 4 plus 2 is 6. So I get, for part B, that f of 2 equals 6. Again, feel free to pause if I'm going too fast. For part C, again, I know I have parentheses already built into the problem, but I'm going to put parentheses in for my variables x. Now for these machines, these functions, we only have one x missing, but in equations where I have multiple x's, for example, something like this trinomial, what we would do is we would look like that. So everywhere you see an x, you would put a set of parentheses. That way you could go ahead and put the input in there. I pop in a 2. Order of operations says I do 2 plus 2 first, which is 4. But it's squared. 4 squared means 4 times 4. That's 16. So f of 2 is equal to 16 for part C. Note that, having done A, B, and C so far, these are 3 different functions. These are 3 different machines. They're all getting the same amount of money, right? 2. They're all getting the same amount of input, 2. But each machine will give me a different output. So imagine a machine where I give it $2 and it pumps out $4. Or one where I pump in $2 and it gives me 6. Or one where I pump in a 2 for this one, it gives me 16. So you'll note that the machine, the function itself, does something different with the same input. Finally, for our last one, I want to plug in a 2 here and a 2 here. We've seen this before, right? This is first. We get a 4 from here. The squared only belongs to this 4 that I got. 4 squared is 16. 16 minus 2 is 14. So for part D, we find that f of 2 is 14. In other words, for this function, if I have an input of 2, I get an output of 14.